Hello students, welcome to We Learn. In today's video, we will see about Aufbau Principle. So what is Aufbau Principle? It dictates the manner in which electrons are filled in the atomic orbitals of an atom in its ground state. So it completely deals with the position of an electron in the atomic orbitals of an atom only at its ground state. Okay. See, it states that the electrons are filled into atomic orbitals in the increasing order of the orbital energy level. According to the Aufbau principle, the available atomic orbitals with the lowest energy levels are occupied before those with the highest energy levels. See here, first 1s orbital will be filled and then 2s and then 2p and then 3s and 3p, 4s, 3d, 4p, 5s, then 4d, 5p, 6s, 4f, 5d, 6p, 7s, then 5f, 6d, 7p and 8s, and it will go on like this. Okay. So once the lower atomic orbitals are filled, then only the electrons will move on to the higher energy level atomic orbitals. Okay. See, the Aufbau principle can be used to understand the location of electrons. In various cases, we will consider the valency electrons. So this Aufbau principle will actually help us to understand the valency electrons of an atom and its corresponding energy level. For example, we know the valency of carbon is 4, right? So how we can find out that by using Aufbau principle? For example, the valency of carbon has 6 electrons and its electronic configuration is 1s2, 2s2 and then 2p2. So what is the outmost energy level? 2. Okay, second level. So how many electrons are there in it? 2s2 and then 2p2. So altogether there are 4 electrons in the outermost shell. So carbon has a valency of 4. And it is important to note about the Pauli's exclusion principle and Hund's rule. We will see about the Pauli's exclusion principle and then Hund's rule. So Hund's rule states that of electrons will not take place until that orbital subshells is singly filled. Okay, we see here 2p level, all the electrons must be singly filled, then only pairing must be taken place. See here, before singly filled, pair has been, okay, this is px orbital, py orbital and then pz orbital. In tx, the pairing has taken place before everything is singly filled. So this is wrong. As per Un's here opposite spin. Okay, so it is correct. Here the orbital is filled with same spin. Here also same spin. So these two are incorrect. See, hydrogen, how it is filled using Haber principle. So what is the atomic number of hydrogen? It is 1. So 1s in 1s orbital, 1 electron is filled. Helium is 2. So 1s, after it is fully filled, pairing has taken place because 2s orbital is a higher level orbital. So the lower energy level orbital must be completely filled. Then only I move on to the next level. So lithium is 3. So once the 1s orbital is completely filled, the other remaining electron will move on to the 2s orbital. The atomic number of sodium is 11. Okay. So first 1s orbital is fully filled. Next 2s orbital is singly filled and pairing has been taken place. Next in 2p orbital also all the orbital suborbitals levels are singly filled and then pairing being taken place. Then one electron will move on to the 3s orbital. Similarly, for oxygen, the atomic number of oxygen is 8. Okay. Here, 1s orbital is fully filled and 2s orbital is fully filled, and in 2p orbital, all these subshells are singly filled and then pairing has taken place. This is how the Haber principle will. Okay, next we will see about the salient features of Haber principle. According to principle, electrons first occupy those orbitals whose energy is lowest. So from lower to higher energy level, first 3s, 3p, 6s, 5p, 4d, 5s. So like this, it will go on. So you can see here 3p orbital is filled, then direct electrons will jump to 4s orbital, then it is coming back to the 5p orbital. So for that, we have to understand about n+1 rule. To understand n+1 rule, we need to have some idea about the principal quantum and azimuthal quantum. What is principal quantum number? It is the main energy level or the shell of the orbital. So for example, if we say 1s orbital means the principal quantum number is 1. If we say 2s orbital means the principal quantum number is 2. If it is a 3d orbital means principal quantum number is 3. If it is a 6d orbital means principal quantum number is 6. Next one is the azimuthal quantum number. We have many kinds of subshells like S, P, D, F, and it goes on like that. Okay. So S orbital means it is 0. Azimuthal quantum number is 0. And if it is P means 1. And if it is D means 2. And if it is F means 3. And it goes on like that. Okay. Let us calculate the n+1 rule. So for that, and before we could calculate, you have to be clear with one thing. So to understand the energy level of an orbital, first you should calculate n+1 rule for each of the orbitals, and then if the n+1 value is lower, then that will be the lower energy level, and that will be filled first, and then the higher energy levels will be filled later. If two orbitals are having the same n+1 number means we have to consider the n value alone. Lower the n value will be considered as the lower energy level, and then the higher one will be considered. Okay. See here in this diagram, the energy of the 3d orbital is higher than the 4s orbital. See here, the 3d orbital is higher, okay, and the 4s orbital is lower. How we have calculated? I have already told for 3d. Okay, 3 means the principal quantum number will be 3, and for D, S, P, D. D means 2. Okay, so it is 5, and for 4s, 4. So principal quantum number is 4. And what is the L value? Azimuthal quantum number S means 0. Okay, so 4 plus 1 is, 4 plus 0 is 4. So first the 4s level has to be filled at first, and then the electron will move to the 3d orbital. See, here it is given in the same format. First the 3d level will be filled, and then electron will move on to the first the 4s energy level will be full, then the electron will move on to the 3d level. Okay, and see how it works. For 1s, we know n is 1 and s is 0. Okay, so 1 plus 0 is 1, and for 2s we know n is 2 and s must be 0. Okay, so 2 plus 0 is 2, and for 2p, 2 is principal quantum number is 2, and for p the azimuthal quantum number is 1. So 2 plus 1 is 3. And for 3s, similarly, the principal quantum number, that is n, will be 3. And s means 0, so it must be 3 plus 0 is equal to 3. And for 3p, the principal quantum number, that is n, is equal to 3. And p is p. So p, the L must be 1. So 3 plus 1 is equal to 4. And for 4s, 4 is equal to 4, and for 3d 3 plus 2 is equal to, because s, p, and then d, so 0, 1, and then 2, so 3 plus 2 is equal to 5. Like this we have to calculate, and we have to compare the values. So greater the value, higher will be the energy level. Okay, so in this manner, 1s is equal to 1, so it is the lowest, and then 2s. 2s means 2, and then the electrons will move on to the 2s orbital. Like 2p is 3. Next to 2p orbitals will be filled. 3s is 3. Okay. So here 2p and 3s both have the same n+1 value. Okay, so we have to consider the principal quantum number. Here 2p means principal quantum number will be 2, and for 3 quantum number will be 3. So 2p must be considered as the lowest energy level, and it must be filled at first, then only the 3s level has to be filled. Similarly, for 4s and 3p also we are getting 4 and 4. So the principal quantum is 4 in case and 3 in sixth case. So 3, this must be the lowest energy level. Electron must be filled here at first, and then it will move on to the 4s orbital. See here, 3p will be filled at first, and then the electrons will move on to the 4s orbital. So by this energy of orbitals increases can be determined with the help of n+1 rule. Okay, n+1 rule is nothing but the sum of principal and azimuthal quantum numbers, and lower the n+1 value corresponds to the lower orbital energy, and if the two electrons with the same n+1 value, we have to consider the n value. Lower the n value will be considered as the lower energy level, and then the higher n value will be considered as the higher energy level. So first the orbitals with the lowest energy level has to be filled, and then only it will move on to the higher energy level. So it will be following this order: 1s, 2s, 2p, 3s, 3p, and so on. Okay, and there are few exceptions in this Aufbau principle. The first one is the chromium. So considering, see, always, in a subshell, if all in a shell, if all the subshells are singly filled, it gives extra stability to the subshells. Okay, and even if it is fully filled, again it is going to give more stability to the atom. Okay, so always, the atom will try to push the electrons in such a way where it can attain half filled subshells or else fully filled subshells. An exception is chromium. Actual electronic configuration as per Aufbau principle must be 3d4 and then 4s2. But what chromium will do to attain extra stability, always, the atoms will try to attain its own stability, okay, rather than being unstable. So it will, one electron from the 4s orbital will be moved to the 3d orbital just to attain the half-filled subshells, which will increase the stability of an atom. Okay, similarly, the fully filled subshells can be seen in copper. Okay, the actual electronic configuration must be 3d9 and 4s2. But to attain stability, one electron from the 4s orbital will be moved to the 3d orbital, thus it gives extra stability to the atom. So this is the pictorial representation. Actually, chromium, the atomic number 24 has to be filled like this. But to attain extra stability, one electron from the 4s orbital will move on to the 3d orbital, thus the 3d subshells are half filled, so it gives extra stability to the atom. Similarly, in copper also, see, the 3d orbitals must be fully filled if one electron from will be fully filled if one electron from the 4s orbital moves to the 3d level. So to attain this extra stability, one electron from the 4s orbital will move on to the 3d orbital. Okay, these are few examples of writing electronic configuration. So the atomic number of sulfur is 16. So it must be filled as 1s2, 2s2, 2p6, 3s2, and then 3p4. Okay. Next one is nitrogen. Okay. So how it must be arranged? Like we have 7 electrons in the nitrogen atom. So it must be filled as 1s2, 2s2, and then 2p3, and so on. Not so on. It will stop with 2p3 because we have only 7 electrons. So that's all about Aufbau principle. If you have any doubts, please kindly mention in comments. Thank you so much.